So we would like to invite Professor Matsuoka, who is the moderator of this session, and Professor Matsuoka can introduce the theme of the session and also panelists. Please.
Okay, I'd like the panelists to come up on the stage, please. Martin, Thomas, and Kitano-san. So this session is it's a concluding session, but also a session a little bit different from the previous ones, because we're going to talk more about information technology, high performance computing, artificial intelligence, and handling very large data, but in relationship to how these technologies may either contribute to realizing this goal of having a sustainable economy by this like valuations of the nature per se. And these were mentioned several times by our previous panels. Or are there problems? Are there problems like, for example, the AI data centers, which are a whole bunch of supercomputers using gigawatts of power, as well as there are issues with how AIs are trained, which may or may not benefit this movement towards sustainable economy. Rather, the objectives of these large hyperscaler AI hyperscaler giants may overcome the societal desires. So we have three expert panelists from different disciplines. And hopefully this will be a fun concluding panel. We have 38 minutes left, so I'd like to have each of the panelists introduce himself and also have provide some short statement, okay, regarding the subject. Okay, I'd like to start, Martin.
Yeah, I'm the family therapist, but this time around in a different capacity. I am, on the one hand, I'm leading a doctoral school at the University of Innsbruck for industrial systems in transition, but mostly I think I am linked to this topic because I am the CEO of a nature fintech company, a company that wants to build the trusted infrastructure for an age where nature matters. What we really do is we try to give every pixel of the planet an ecological passport with regard to the stocks of biodiversity, of carbon, of soil, of water, in such a way that we can establish a new quality of contractual relationship between all those land stewards that Tom talked about this morning, who are providing nature capital, and those who need it, which increasingly is all of us, as the last conversation I think has shown. And that we do based on a completely new generation of AI that is now available. And I think that is also the topic of this conversation, where we are asked to discuss what are the pros and the cons, what is the light and what is the shadow at the place where nature and AI and high performance computing meet. I think that's the exam questions that you gave us. And if you think about it, where they meet, that's currently still very much a twilight zone with darkness and light. And I could think about three that are particularly on my mind right now. The first one has to do with super transparency. The second has to do with super intelligence. And the third one has to do with supersession. Will we be replaced by a different species altogether? And I think we can't have this conversation without quickly going there. Super transparency is very much the world in which I currently live, where we are trying to build more and more indicators, more and more predictive models, more and more high-resolution data sources that help us to understand the state of nature, that help us to define what ecological integrity is really about. We are so successful in doing that, and that resonates with what Tom said earlier, that we are starting to confuse everyone, that it's very, very hard for those who are in need of nature capital and who have investment need in nature capital to decide what methodology to trust. And so here I think and every time in the twilight zone, we also need to have a solution to get us out of it. And I think here the solution is going into a direction where we need to create public cadastres. In Germany, we've just started building the first national nature cadastre, so where every plot of land actually has an identity where we are tracking the stocks of biodiversity, carbon, water and soil, so that is available to governments, that it is available to every investor, and through that we would make a major leap in the way we can actually trust the transactions, the investments that we make. So I think apart from building all the technologies and the cars, we also have to build the road on which these cars can drive, and we have to set up the rules to do that. That is twilight zone number one, the super transparency. Super intelligence is a second thing that we need to have an answer for. If it's true what data scientists are telling us, that in 3 to 5 years we will have AGI and super intelligences, that also means that all the investment and capital allocation decisions will be made by AI. And currently they would be done in a world where the only value of nature comes from extractable timber, but it doesn't come from the value of nature itself. So we will run into a super allocation of funds and which turn out to be a bet against nature. If we don't establish value signals for working nature over the next 3 to 5 years, then we might have lost an opportunity. And that again is something that where we can work against. We can establish, we can make sure that we give every plot of land, every hectare, an ecological integrity index, a biophysical value. We can give it a financial value. In our system, we call it an integrity value. And we can establish the risk pricing models that we need that tell us how much should we be prepared to pay for that integrity of nature. If we don't do that, then we've lost an opportunity, and a new form of super intelligence will completely crowd out nature out of every economic decision. And the last one, of course, is very evident, which is supersession. We are currently in the 6th extinction event, and we saw the numbers. And that has to do with moments when a smarter species meets a less smart species. We have been there before when the Cortes and the Pizarros went to Latin America, when we extinct the mammals. Again and again, there have been these moments in history, and something similar might be happen to us. So we might, in fact, very quickly move from a 6th extinction to a 7th extinction, because we are seen as interesting matter and interesting carbon to solve other problems of a new intelligence. Here again, there is a way out, that we have to implant a maternal instinct into the algorithms that we are currently building. We have to build in responsible code, we have to build in institutional oversight, we have to make sure that these models we are building are also have access to simulations and to code training models that show that there are other models of optimizing than just competition, but also those of cooperation. So I think this is all of these and increasing grading are elements where AI on the one hand is providing us a huge opportunity, unheard of in the past, but at the same time where we have very little time left to make design choices to make sure it's not turning against the objective of this conference, which is to make nature internal to our wealth equation.
Well, thank you. And just a note that the modern supercomputers, such as the one that we have at RIKEN, the Fugaku, which had 160,000 compute those, so-called exascale machine. Thomas's Center has a machine that has 11,000 state-of-the-art GPUs. Again, sort of an exascale machine. And these machines provide immense AI. This is orders and orders and orders of magnitude more powerful than your standard laptop. So they provide immense simulation capability, immense AI capability. But we do need to build the models in order, you mentioned briefly. Just having data is not sufficient. You have to have the models, because any economy or any sort of ledger investment, they have to have a model. Otherwise, you cannot make these judgments. Not even the super AI can make judgments without models. So how do we build these models? Well, it's very complicated because it hasn't quite been done, but maybe done partially in areas like climate, weather, and so forth. So with that, I'd like to have Thomas introduce himself and maybe give some insights.
Thank you, Satoshi. Thank you very much for the invitation. It's a great pleasure to be here and very, very interesting to listen to you all. I am a physicist. I'm a professor for computational physics at ETH Zurich, and I direct, like Satoshi just said, the National Supercomputing Center, CSCS, in Switzerland. And we are, I think, probably the largest academic facility of this kind globally. And as such, we are committed, so we have many thousand GPUs, which is not much compared to the large industrial centers. But we are committed to openness, transparency, accountability, compliance. And we do this as scientists, because this is the tradition in science, and we do this in AI as well. And we have just a month ago, together with the AI centers of ETH Zurich and EPFL, released a completely open model where we are compliant with the data. The data are published, the recipes are published. The model is called Apertus, which is Latin for open, and is a first step in the direction of a fully attributable model, large language model for science. That is just an example of what we are doing. Now, what is relevant in this community is that since decades, the center I lead and the Swiss meteorological agency, Meteo Suisse, have been working together. So we have, since I'm there 17 years ago I joined, we have been working with Meteo Suisse to, their job is to collect data in Switzerland, which is a very important contribution to the discussion that we had today, that the meteorological services have, and develop numerical weather prediction models in a European collaboration, and we work with them to implement these models, design the systems, and run the weather forecasting operationally. And we have this is an exceptional collaboration that has helped us understand how to build the infrastructure for weather forecasting and also for large climate simulations. And this is where, and then in Europe, we have this collaboration of the weather services together with, joined together in the European Center for Mid-Range Weather Forecast that run this global model called Integrated Forecast System, or IFS, which in the US we call the European model. And it shows how collaboration can lead to a very important quality. And you also see a pattern that I think could help the discussion on global commons and local commons, how a global collaboration, multinational collaboration can create a global view that is very reliable and high quality, and at the same time you have the national services that collect oversee the local commons, and the two work together. And where I see one of the biggest promises today is the community, the weather forecasting community has really endorsed AI and are moving now towards forecasting weather using AI models. So there are a number of research projects. ECMWF has released AIFS, which is IFS but with an AI based. And I see even more potential where we look at if we have fully attributable language models, you can see the weather models as a multimodal extension of these. And that leads to a system where the physical modeling can be brought much closer to economic and cultural considerations. It's also challenging because it's the first time that we, on the engineering side and science side, natural sciences are faced with cultural topics and have to take a responsibility in that area. So that's why I think the dialogues like what we have today are excellent for us, opportunities to engage.
Okay, thank you, Thomas. Well, you gave an example of the Swiss Meteo Swiss. Of course, we at RIKEN were collaborating with Schultess, or meteorological agency, and but there are other domains. There are satellite images. There are like earthquake sensors. There are various sensors. There are various data sources, and there are various simulation models. And the problem is that these are especially in Japan, many of these data sources are private and are not subject to consumption by our big supercomputers. Same with industry. Well, industry, there are lots of factories and lots of economies. There are various distribution networks of supply chains and so forth. But a lot of these data are fairly private and not revealed to the public. So we have the capabilities, and we will increase our capabilities moving forward with immense compute power, immense AI. But we also need the community to endorse the fact that all these data need to come together and create a model, a mathematical model, coupled with AI to make these decisions, or else, of course, coming up with a formidable story for the investor to be able to invest in these types of assets will be difficult because people won't know what they're investing in. Okay? So give both academic and industrial view. Most of you may know Professor Kitano, but also he's half Sony, he's half Okinawa professor, and my old friend. So please, Kitano-san, you can say whatever you want, since you have both sides.
Yeah, well, thank you very much for inviting me for this panel. I mean, my specialty is in AI, large-scale computing, as well as the biomedical science. It's kind of interesting. I think about this. Like, let me take a view as the bioinformatics science, biomedical science. Assume that planet Earth is patient number one. Okay, how are you going to cure that, or how are you going to treat that? So in the biomedical science, you need diagnosis, you need precautionary measures, you need preventions, but the fundamental thing, you need to have the intervention that will be effective. Intervention that can prevent patient to be sick, or intervention that can cure the disease, and that is fundamental. So when you do the, for example, like a personal genome studies or like all kind of like a predictive measures, many of them has a problem because even if you predict something, you potentially likely to be some disease in coming days. If there's no intervention, that's not useful because you're just giving the patient the verdict, you're going to have a problem. And then the patient come back with what I'm supposed to do is, well, nothing. You have to play for the good, things like that. So I think the same thing happens to this planet Earth. Assume planet Earth is like a patient number one, and then what is the interventions? I think it's the intervention all that matters. when I was undergrad at ICU, I read the book, a couple of books which affected me. That's one, Emory Robbins, Soft Energy Path. And another one is Rome Club Report. Okay, Rome Club Report is very interesting. And then I think they predict that, 2030 is a critical point. Although the reason was actually the oil crunch. Now we have a same stage. We're in the critical moment 2030. But for a different reason. But I think the prediction is right, regardless of the reason, which is remarkable, actually. So I think we are converging into the agreement that we are in a critical moment. So the question is, what is intervention? We can have all the sensors, we can have a simulation to be able to say that we can have a problem, okay? But we have to really, in a COVID time, economy slowed down dramatically. For example, in Singapore GDP dropped half, 50% reduction in 1 quarter. In Japan, I think we have a 20 to 25% reduction in GDP 1 quarter. Then what happened is the air pollution goes down, but after COVID, business as usual. We're probably much worse than before. At the same time, the first 6 months of the COVID, everyone locked down. That is a degree of economic control we have to impose to reverse the trend. And that's not sustainable. We did global experiment to actually slow down, restrict economic activity to meet the Kyoto Protocol or whatever it is, CO2 reductions. And we have found out that is intolerable. Okay, so that means that we have to come up with other interventions. We have done the intervention accidentally, and it turns out it doesn't work. Okay, so one of the things is that Sony does is Sony Computer Science Lab. We have a Sineco Culture project, which is all kind of biodiversity-driven, agriculture to enhance the biodiversity at the same time a stable yield. At the same time, Funahashi is the guy who's running it. He's going to Africa, try to get the green belt using Sineco culture from east to west of Sub-Saharan Africa. So he's thinking big. I don't know how that uptake, but at the same time, the problem I see with this kind of initiative, idea is great. Locally, that's successful. Can it scale? Can it make a business out of this? Without business opportunity, things doesn't work. So. Here, I think we're talking about extremely important thing. Matsuoka-san's here, Gonogami-san here, all the important people here, but how many people we have? Because people think this is important, but people think this is not going to be the business. People don't take it as their own agenda today. So we probably need to change that. We need to come up with idea how this sustainability issue will be the business. And then how we can actually sustainably grow and do it in a scale. I think that's really, I don't have an answer, but I think that is really the single most important issue is can we make a sustainability as a business agenda? I think that's the single most important thing. And then that actually combined with a proper intervention that we can save this planet.
Yes, thank you. Hello? Yeah. Thank you, Kitano-san. Yes, very important points. One is intervention, and in order to assess the effect of the intervention, of course, one way is to actually do it, like with COVID was a grand experiment, but of course it had its consequences. The other is to be able to predict the future via very large simulation AI, just like we do with climate simulation, weather simulation, or any sort of simulation that we do in our big machines, either using first principle physics technique like traditional sense or using empirical methods like AI. But irrespective, these are, we're now at a point where we might be able to do these experiments by building these effective models. In fact, during COVID days, we have built an economic model with Fukaku, you know about that, where we did predict that the 25% downturn in economy, and this was done from modeling the entire supply chain of Japan and doing tons of simulation data. But this could have been done even more in more detail by having other parameters, which may or may not have been important. But and we did a lot of also simulations on how, if people dine in restaurants, what would be like the effective transmission rate, and with or without these mitigation measures, which is very important for the spread of the COVID. It's not your individual wearing masks, which is important, but actually modeling a transmission rate was very important. Then we communicated that to the committee, where Kitano-san was a member, and said, well, with these measures, maybe we can make the restaurants open, and the restaurants were open in Japan, which contributed to less downturn of the economy. So these types of experiments are important, but also it's not just doing intervention, but as you point out, these people, for things to be sustainable, it still has to be to involve the mass, global mass, because we're talking about a global problem. And also, it has to be economically viable. So the model must show that we're not just cleaning up the environment per se, but that we can make a combined decision on improving let's say the climate, but also it'll be generating values to the society. So these combined models of both the physics and the entire Earth system, but also combined with modern economic models, and in fact not the macroscopic model, both macroscopic and also microscopic models, because we're talking about microscopic phenomena as well here. But these are things that have not been achieved. So we have to have these models, then we have to have on top of that ideas to make this whole effort money-making, so that it's sustainable. Okay, so we still have 15 minutes left, fortunately, and I'd like to pose some questions to our esteemed panel, now that we have opening statements. So can you put up the questions, please? Okay, so one click, please. So these are general questions. One more click, please. Can you click? Oh, yeah, okay. Yeah, one more click. One more click, yeah. Okay. Okay, so if nature has a clear economic value, that's the statement that this community would like to make, then how does that change the business case for building massive AI HPC system? Because we all know that hundreds of billions of dollars are now being spent on building very large supercomputers to serve the AI needs. The likes of OpenAI, Google, Amazon, Microsoft, Azure, they're all Anthropic with AWS. They're building these humongous data centers. These are gigawatt data centers. A gigawatt is a nuclear power plant. And with hundreds of thousands of GPUs, size and scale of Fugaku, but replacing all the CPU with GPUs, or even bigger. So billions of dollars are being spent, but mostly for like ChatGPT or things like improving business. In our case, RIKEN, we're doing lots of stuff, trying to do lots of stuff for improving our science, AI for science. But if nature has this immense economic value, which is untapped, how does it change? Will it affect, or how does it change the business case? Because there are, again, billions of dollars being poured into this. So how do you incentivize these investments so that these investments, AI and HPC, will see the value of the nature as a value, will indirect value due to these investments? Okay.
Yeah, thank you. That's an interesting question. We've been sitting here all day wearing sort of happy about how nature has value recognition today, and yet we see massive investments into the technological infrastructure. that is almost ahead of the market when it comes to valuing nature. So there are these significant Earth system foundation models being developed right now. There is Earth Alpha Foundation, there is the Microsoft planetary computer, there is Earth 2.0. All of this is happening, massive investments at a moment where you would say, look, this is a bet about a future where nature finally comes in the money. So we could almost take that as a positive signal that all the smart brains who write business cases in major AI and HPC worlds sort of are expecting our nature case to become real. And I happen to think, I mean, otherwise probably we wouldn't be here, that this is also a bet that could work out. I think there won't be a bank, there won't be an insurance, there won't be any company on Earth that in the future doesn't need some kind of AI-based computing that allows them to take all the decisions, all the capital allocations that will somehow have to do with the complexity and fluidity of ecological systems. So I think this is happening, this is real. Of course, interestingly, if I think about it, it also happens the other way around. If now nature comes into the money, then of course that also will change the way in which we are building out that infrastructure. The IT industry will be a 1 peta kilowatt, a 1 peta watt hours, sort of, we have to get, sort of, you have to teach yourself how to say that, a petawatt hour industry, it will be using something like 7 billion cubic meters of water a year, and we don't know how much land use actually comes with all the infrastructure that we are building right now, all these pictures that you see from the US. And if that happens at the moment where water and land and CO2 has a price, then of course we would build that differently. We would probably build in analog loops. We would make sure that we go for very efficient AI models to make sure that we that we can actually cope with that new value that we have given to nature. And so I think there's a very close relationship. It goes both ways around.
Okay, thank you, Thomas.
Yeah, the business model in HPC I've been describing before already exists. The AI is bringing things closer to the economic reality. So I see really great opportunities. I've seen up to now the customers of Meteoswiss, downstream customers, which is the energy grid, the air traffic control, the transportation system, agriculture, etc., etc. And what AI will do is bring these closer to the model and make the whole value chain much tighter and much more effective. I'm convinced of that. Of course, this comes at the price. And we see this already happening now, that up to now, individual countries on the public side would shoulder these investments. And now we see that this is no longer possible. And so this requires multinational global collaborations. And I believe organizations like ECMWF has shown how this can be done effectively. Unfortunately, when it comes to policymakers from different countries working together, that's not always as effective. We also see symptoms of that in Europe even. But maybe the natural resources, these things require, force us to go that way. We will need 100 megawatt watt scale or gigawatt scale facilities. Actually, I've been saying this 5, 6 years ago, even more, 7, 8 years ago, before all this AI boom started. And I was hugely unpopular in Switzerland for making statements like this, because it means that we can no longer build the systems locally. We have to move them to places where they are that are ecologically more appropriate, which in Europe is in Northern Europe. And the biggest national egos are not in Northern Europe, they are in Central Europe. So we build the system in the wrong places. And that, I hope, maybe the tough challenge we had is forcing us to do the right thing. I hope so.
Yes, thank you, Thomas. And just to note that, in Japan, there's a company, Weather News, which is very profitable for the exact same reason. There are lots of these downstream tasks that the companies actually are requiring, like transportation companies, even like bento companies, because they need to know the weather, right? How many bentos to make. There are lots of downstream tasks where the capturing the nature would actually serve profitability in their businesses. So how to come up with these models, whether computational, pure computational, or with AI, that to investigate these downstream tasks that will allow profitability in various sectors of business will be immensely important for the global movement towards this type of sustainability. So it's not just saying, yeah, we have this grand ideal that we want to do the right thing. We got to really drive people's motive, incentivize people, and by identifying all these downstream business tasks that would benefit the industry and the economy. Well, of course, you know all that, Kitano-san. So, do you think Sony or you in general, will change or what?
Well, I think to make a massive AI and HPC positive, we need to have three factors. One is the mitigations, and probably adaptations of the impact of the creating massive AI and HPC, and the regeneration of the nature, or natural capital. So mitigation-wise, I think we can have some power generating resources. Some of the companies in the US have put that into the big gas turbine, and then probably use that thermal energy to generate it. So they try to do. Yeah, so it's kind of it's not gonna solve the problem, that it will mitigate the problem. So it will be a little bit mitigation issues. And then the adaptation is if you do anything, you change things, things need to adapt it. But a bigger thing would be regenerations. Certainly, if you get a massive HPC, we're gonna have a power. We need the power, so that will affect. But can AI benefit completely outweigh, and then eventually will make it nature positive as a whole. So it's just like an automobile, right? Automobile actually had a problem. We have a lot of people get killed, but automobile, great benefit to our society. Without automobile, our society don't, exist. We're gonna go back to Stone Age. So I think biggest thing in AI can contribute is AI as a scientist, AI scientific discovery. Can we accelerate the scientific discovery in a massive scale, so that we can have a material discovery or carbon absorptions, better understanding of nature, how the ocean will absorb and discharge the carbons, which is very complex, and then how the microbial out there, will actually interact to actually change things, or the soil, those system is vast and so complex, and it's beyond our cognitive capabilities. I think I'm I'm firmly believed AI scientists is the way to go. All the complex systems that we are facing, it's beyond our cognitive capability. We are not good in science or the complex systems. So we need to rely on AI to be able to some of the key questions that we might actually have solved. So if we direct, my suggestion would be direct quite substantial energy and capability and talents of the people, of the not just the AI expert, but also a domain expert, to build an AI scientist to be able to solve the problem. That would be the last hope.
Yes, I totally agree. That's what we're doing. Okay, so we're running out of time, so one last question. We have tons of questions, but one last question. And keep your answers short, please, my dear esteemed panelists. Can you, oh yes, my clicker, yes. Wait. What is the most direct way for you to connect local comps? Well, we already kind of answered that, so let's move on to the next one. And yeah, I know. All right, just a short quip, please. Okay, so is the current AI development model driven by a few tech giants fundamentally compatible with the principle of global commons? Yes or no? Or can it be?
Well, I think no. I think this is a time that we see now, something new happened, things go out of balance, and I'm convinced they will come back into balance.
So you think there will be more global cohesive effort rather than being dominated by...
This is the world is going to catch up with these companies. I'm very convinced of that. And it's our duty to help make this happen. Okay. And then we will see how things even out. Okay. Let's talk in 5 years.
Okay.
Yeah, I mean, I'm on this UN advisory board on AI for Secretary General, and one of the major discussions at the UN board is actually make no one left behind, how to actually make a benefit to AI for all the member states. You know, so I think that this is a global common issue has been one of the key pillars for the UN report. You know, at this moment, I think tech giants are tons of money to burn it to be able to create best models. So at the same time, this is early in the game, very, very early in the game. Like if you take 10 years from now, 20 years from now, I think it's going to be dramatically changed. And then we might have emergence with global commons. For example, Swiss has Singapore has a sea lion, man lion, and then all the sovereign AI try to go for the global commons. I think one of the things is that can we actually get a proper network of all the stakeholders, build emergent global commons that'll be adaptive, and then all the fair representation of all the culture and the localities as well. That is more driven. So I think if we can create the foundations to global commons. So this is more like a statement is current driven the free tech principle global commons? No, but I think there will be emerging global commons by the stakeholders.
Yes. Yes, the current models are not necessarily transparent because we don't know what data they trained on, or of course closed models, obviously we don't know the weights and so forth. But the efforts to make the AI transparent and make them more capable by assimilating more data from the entire environment, the entire society, from Earth. Those are very important activities. But again, like Dee's pointed out, it needs to be a global effort. It needs to be a global effort, a common effort across the globe, so that we can build these immensely powerful models, but at the same time, these are models that we know what they are. We know their origins. We know what they do. We can control them, or which we know the provenance. So it's much more akin to serving us rather than being an endangerment to society. So this community, and also a community like ourselves on the computing side, we should work together to achieve this goal, which is very important, that working for this commonality, this commons, towards building better society and make money at the process will be at the same time, will be very important towards the future direction. And RIKEN, my boss Konokami-san has stated earlier, that was actually a statement that RIKEN will continue to invest and make sure that we have all the capabilities, scientific capabilities, to make those goals happen. Okay? So with that, I'd like to conclude the panel. Thank you, our panelists. I'd like to give a big hand. And hand it over to our MC.